Hello, and welcome to our panel discussion, AI Factory and Tuning Infrastructure into Scalable AI Production. I'm joined today by Shawn Rosemarin, Vice President of R&D for Customer Engineering at Pure Storage, Tom Nadeau, Co-Chair of the Evenstar Workstream at Open Compute Project, and Ted Weatherford, Vice President of Business Development at Xsight Labs. Welcome, everybody. I'm going to start off with an audience poll for those who want to participate, and it simply asks, where are you today in your enterprise AI journey? And at the end, we will read the results. So let's jump right in. Before I ask about what an AI factory is and what it can do, I'd like to talk a little bit about the elephant in the room, which is the fact that so much of the news today centers on the hyperscalers. But what about the enterprise and the big enterprise or the SMB? And what are the CIOs in those organizations worried about when it comes to actual AI infrastructure buildouts? So I'm going to turn my attention to Shawn, who can start off with an answer. Shawn, what's your opinion on that?
Yeah, so look, the news and the headlines over the last 12 to 18 months have largely been focused on the hyperscalers. We've seen well in excess of $500 billion invested in data center build-out, as well as commitments for the future, as we've seen from the earnings reports of those big hyperscalers. The enterprise themselves, there is no particular number, but it looks like it's somewhere 20 to 30 billion. The reality is you're still looking at 90+% in the hyperscalers. And I think if I'm an enterprise CIO or CTO, I'm kind of looking around and saying, hey, this looks interesting. This looks like the next big trend. This looks like we've got 15 years to grow into this exciting new productivity booster, call it human plus machine. How am I going to use it? But more importantly, what can I afford to invest at this particular point in time? Invest in looking at use cases, invest in building out infrastructure, invest in modernizing people and process. I'd say we're still early. I think there's a lot of POCs and pilots, but ultimately the big investment at this point has still remained with the hyperscalers.
Okay. Tom, do you have anything you want to add to that?
Yeah, just taking off from what Shawn was saying, I think one of the things that I'm seeing, both in the industry at Open Compute and in my day job, is what Shawn is saying. There's an evaluation happening at this point in the enterprise space where people are trying to figure out where to invest. Right? Is it we're talking about AI factories, but is it appropriate for every enterprise to build an AI factory, like a data center sort of implementation? And it harkens back to the same questions we have with every technological change. Do I need to build all of this myself, or do I need to invest in purchasing a service or whatnot?
Right. And Ted, you're kind of in the chip DPU world. Do you have anything from your perspective in terms of, how people are evaluating that?
Sure. You can look at the uptake of DPUs inside servers with or without GPUs that are bought and sold and used in the enterprise, and you can definitely see that it's lagging the cloud, right? So people are building out servers with GPUs, and they are putting DPUs in them, but the scale is it's 100 to 1 right now. So you're not seeing a lot of uptake in the enterprise with the DPU. So I'd say that would support the exploration phase or the deer in the headlight phase. What do we do with this? I think it's yet to take off.
Yeah, Ted, let me just bridge on that. So you see, up to now, we've basically been solving all AI problems with what I'll call brute force, which is get the biggest, baddest GPUs you can buy, whoever can afford them, and essentially solve all problems with hardware. And that hardware is obviously GPUs. But we are seeing models not only get more efficient. We saw obviously the DeepSeek moment from 12 months ago. But we're also seeing new architectures. We're seeing edge analytics. We're seeing DPUs. We're seeing advances in Ethernet fabric that are all driving a new paradigm to how we architect for these solutions. So you've got kind of multiple things going on. You've got new and more powerful hardware. You've got new and more powerful models. And you've also got, a wave of new ideas coming in terms of how can we make these models more efficient. KV cache for key value store in terms of kind of that pre-feeding of the cached information. And so it's an incredibly exciting time. But to Ted's point, I mean, I think we're only scratching the surface of what's possible here. And I think the architectures are dramatically going to evolve at a pace that we haven't seen really before.
Yeah, to the point, both Ted and Shawn were making, one of the things I wanted to make sure people understand is that there's a lot of action going on in the hardware space today around this. The obvious is to go buy everything from NVIDIA, et cetera, but there are dozens of companies now out there working on GPU type technology, the networking pieces that go along with this too, and then just the server configuration. Like Ted was saying, servers are getting GPUs by default now. Servers are going in different architectures that might not be x86 anymore. The way I look at it is kind of a spectrum of, there's NVIDIA out here, which is the most expensive thing you can buy today. And then there's maybe buy a service, but there's a space in the middle that we're not talking about, which is these sort of combinations of alternate architectures, really, what Shawn was saying.
Yeah, I think that the products that we're focusing on making are flexible too. You have to be agile. They have to be programmable. I think that's another observation about the GPU that has been powerful, right? Is it is flexible because all of these applications are evolving, and it's going to remain flexible and less hardened for a while. I think in the end, once we know what the killer apps are, things will harden, they'll specialize, and we're seeing specialization now with neoclouds and other approaches, right? But you're going to see things stay flexible for a while. That's one macro observation that I'm seeing, is people don't know what they are going to do exactly. They need some flexibility. So everybody wants performance, but you've got to have some flexibility. I think that's why NVIDIA is doing so well. They're providing the whole story, the whole software stack, and they have a very flexible platform, not necessarily the most efficient platform.
Yeah, there's been an incredible thought there, Ted, where, ultimately, if I want to solve problems quickly, I throw hardware at the problem. And I do think over the last year and a half, we've seen that, right? Because software is hard, and software takes time, and software development cycles and software release cycles are much more complex than simply throw more hardware at the problem. The reality, though, is when we look at enterprises, what's the economic story behind this? Can I actually get to an ROI that makes sense? And we've talked a lot about DPUs and CPUs and GPUs, and obviously if you're Google TPUs, but let's not forget, data is what feeds all of this. And ultimately, is my data ready? And if we just kind of take this category of AI data readiness, that's actually where the majority of the issues are right now, is do I actually have the data to make this business case fly? And is it something that scales? And is it something that's secure and compliant? So Susana, back over to you.
Well, you brought up data readiness, and you brought up the KV cache. So is that changing the game here? And can we talk a little bit about governance and sensitivity tiers, hot, warm, cold placement and things like that? I don't know if you want to start it off, Shawn.
Yeah, look, so if we break down an average AI workflow, you've got training. So I have to take the data and I have to teach the system or the agent about the particular context of the situation. And then I've got inference, which is I then have folks who, if we use LLM as an inference agent, who are going to ask questions to this agent and look for answers. And I want those answers to be accurate. And then I've got archive, which is all the data that I've used in the past that I need to keep provenance of, that I need to make sure I can reference back to. And then I've also got logs. What are people using the system for? What questions are they asking it? What kind of answers are they getting? What is their satisfaction with the agent, so that I can kind of continuously improve it? If you look across that, though, what many organizations are finding is, and this is a really interesting phenomenon, is that while we've digitized the majority of our data, if we think back 50 years ago, we had paper in filing cabinets, we turned those into PDFs, we turned those into databases and spreadsheets and all sorts of applications. But all that data was essentially recorded by humans. That's us. Okay. And frankly, machines don't think like humans. And so a lot of the interpretation and summarization of these documents that was very valuable to us as humans is proving to be quite problematic when we try to train machines. Machines like raw, high-fidelity data, raw video, raw audio, raw interaction, so that they can try to gain and assess full context. when we sort of put a human window over top of that, and this doesn't even talk to all the issues with ETL, extract, transform, load, where date formats don't match and, social security numbers don't match. This is just flat out, machines want to look at high fidelity raw data. And so when we test some of these models and we end up with hallucinations or we end up with gaps, it really does come down to what is the readiness of my core data and what can I do in the grand scheme of the proof of concepts I have with the data that I've amassed, and how does that translate to machine learning?
Right. Okay. And since we're talking about data now, let's talk about the compute mix and placement. And again, this comes back to TED, training versus inference, edge versus core for latency, SLOs. So Ted, what do you think? How do DPUs change the way we view the compute element in the stack?
Well, DPUs have been traditionally used to bring data in from what we call the front end. Okay. And so a DPU is going to provide three principal things. There's a security element to it. There is a virtualization of storage, or virtualization of storage. So storage. And then there's also the networking element. Those are the three pinnacles that a DPU does. The other thing is, depending on the network, the DPU can be the most reliable component, so that when the x86 goes down or the GPU goes down, it can stand the system back up again. So there's sort of a watchdog or a center of trust element that the DPU can often have. So it's just a basic building block for the whole story, and it typically connects over Ethernet and Ethernet on what we call the front end network.
Okay. And Tom, do you have any?
I want to just bridge off what Ted just said. So remember that right now, everything's kind of being treated with the same level of urgency. So all data is being sort of ingested and processed. But what Ted's getting at that's super important is a lot of this can be done near real time. I mean, if I just give the audience an example, if I think of autonomous driving, there's a need for that to be urgent and real time, right? Cars will, and in some cases are already talking to each other about where they are, what they're doing, what's going on the road. That would be an example of something that needs to be done urgently. But if you think of really where most enterprises are, if I'm doing inference and analytics, in many cases, hourly, daily, weekly, a lot of that can then be moved to significantly less expensive and less power hungry hardware. And that's why, these architectures are evolving. And I can't stress enough, and Ted said it earlier, that the only thing we know for sure is that we don't know what things are going to look like 3 or 5 years from now.
Right.
And so if you're building an architecture and you're trying to justify to a CFO, hey, I'm going to make this investment and we're going to build off this in the next 5 years, that's really the conundrum, is across networking, storage, compute, edge. What investments can I make? What choices should I be leaning towards that are going to provide me this foundation that even if everything else changes, I'm still going to be able to reap the investment of this infrastructure.
Right. And I'll turn it to Tom then in terms of architecture applicability, or changes, as you just said. Tom, do you have something you want to add to that?
I was going to say, what related to what Shawn was just talking about is, again, the consideration of what to use, if anything. Like, we need to roll the question back to, should an enterprise be building an AI factory to begin with, or should they be consuming a service from somebody else? Because that really the ROI discussion is, related. That we were talking about this the other day when the four of us were chatting about this panel session. If you remember, we were going back to the analogies of previous technology, right? When we went into the cloud, for example, or, just back when, I think Shawn gave this example, when the internet was fairly nascent. We were talking about really, the data question is really about moving PDFs around as a standardization of the format. And all of these things, I think, are things we need to consider. I think we're making a lot of assumptions that, just because of what's in the news and the sheer volumes of cash that are getting spent on this stuff, that I think there's a feeling of being left behind. And enterprises that I'm working with, are having a hard look at this right now, because it's not a, we've had a number of these cases. You remember the dot bomb thing we had in the 2000s, early 2000s, where we built out fiber everywhere just because we had nothing to run over that fiber, but we're going to put it out there anyway and see what happens. And it's a similar sort of thing right now. And I think what's really interesting is on the hyperscaler side, or where people are developing, that's kind of the factory model, which is really a data center, makes a lot of sense. But as you go down, sort of slide down that graph, I think you rapidly, get to a point where the cost to build it locally doesn't make sense. Although the need to keep your data perhaps local is imperative. And so you see the conundrum that's happening here.
Right.
But I guess my point is, I think we need to back off from some of the assumptions that are being made and do some critical thinking, I guess, about this stuff.
What about if you're a CIO or an IT executive out there and your board really wants you to, they want to make announcements about AI and you just spent $50 million on a, cloud project or something, and you just threw everything into the cloud, and now you're asked to, build a data center or something. So what do they need to do? Do they, how I would like the audience, actually, if they have any questions for the end of the panel discussion for you guys about this, or if they have an opinion, to send it in the chat and I will bring it to the fore. But, how does the CIO right now deal with that, since they can't, or how do they summarize what the net new could be in terms of the human in the middle, and integrating AI into the actual workflows?
You're damned if you do, and you're damned if you don't. If you don't do anything, then you're not performing your job. And if you do something without a profit or ROI, then you're also damned, right? It's a very, very difficult situation.
Yeah, I think where the CIOs goes, and Tom, you said it well with the architects, right? Architecture is more important than ever. And the good news is, there are a lot of fantastic architects around the world that have been solving this problem. But I want to answer your very specific question, Susana, which is, what do you do if you're a CIO? Well, ultimately, if we think to first principles, this is people, process, technology. AI is not solved by technology. AI is solved actually by the modernization of people and process. Now, those are hard. But the good news is there are a lot of archaic, non-human friendly processes that are happening in companies everywhere. We've been using humans. In some cases, we've been using offshore consulting. In some cases, we've been using business process outsourcing. There are a lot of those functions that actually play well to AI, or more specifically, can be augmented by using AI. So call it human plus machine. And you look at something like a chatbot, it's not necessarily that the chatbot becomes all AI. It could, but in many cases, AI is actually helping your customer service reps or your chatbot mechanism become more responsive, give better answers, but you've still got the human interacting with the other human. And I think that's getting missed in some of this, as people are looking at this very binary, like where do I replace humans with machines? And I'll stress again, it's human plus machine. This is the next era that we're in. And ultimately, the board is clamoring for AI success stories because, frankly, that's what's adding to valuations. That's what's adding stock appreciation. But I do think the CIO and CTO play a very important role to assessing the readiness of that company to be able to embrace this human plus machine and really prioritizing what projects are in a place where we can launch them into POC or limited production, probably in the cloud, test them for their accuracy, test them for their feasibility. And then just like we saw with e-commerce and the advent of the internet, once those workloads have matured, then I think a majority of them will actually get deployed on-prem due to data sovereignty and compliance.
And implemented in a more efficient way too. Remember, we were talking about this the other day around e-commerce. Remember when e-commerce really came on the street, there were 5 million companies doing what essentially was fronting a credit card transaction. And we figured out over a couple of years how to shrink that down and optimize it. Now, how many companies are left that are doing that? And it's really, that came because of what Shawn was just saying. Like, companies figured out how to refine their existing process or optimize their existing process. They didn't throw it all out. Some did, some tried. And that's that binary thing Shawn was talking about. And that's the folly, I think, today with a lot of the sort of over-promising around the technology today. I mean, what I've found, like, during my day-to-day operations is that it's an augmentive experience. And if it's augmented in the right way, it actually is additive. If you're immediately going after, like, let's replace everybody in this department with this one tool, I think you're going to be disappointed.
Right.
And we're seeing that already, right? And it's similar back to, and the other analogy I think we were talking about the other day too is the offshoring. It's a similar sort of thing. Like, let's move the processing over here because it's less expensive, but that might not necessarily be the business case.
Right.
What do they call that, Tom? Your mess for less?
Right.
Well, I have
somebody else's mess.
I have a question here from a CEO. He says, are AI factories building to manage the storms that neoclouds will be generating? Will AI factories act more like ports for the clouds, in parentheses, ships, to have safe harbor for power? Anybody want to take that one?
That's an excellent question. Look, we're talking here, the question really centers around edge core cloud. So let me touch on that. When the cloud first originated, you had folks standing on stage at reInvent back in, I think it was 08 or 07, saying, we're closing all our data centers. We're moving everything to the cloud. Since then, we've kind of seen this evolve. The cloud is another place to run applications where the operating model, not the cost, the operating model has been deemed to be much better than what we can run on-prem. Standardization, pay for what you use. But the reality is the cloud is just another operating environment now. And so when you think about AI factories, you're bringing up an excellent point, which is, am I going to need standards in terms of how workloads can run? Okay, remember, data gravity means wherever my data is likely where my training is going to sit. So the training and the data sets could sit in the cloud, but I may be doing inference at the edge. I may be doing inference closer to my customer base. I may be doing inference in a particular secure instance. So the key across all this is the connectivity, the seamless ability to move and scale workloads within the cloud, within the data center. Now that has networking implications in terms of how my network is set up. That has data implications in terms of what's the data plane that I'm actually using to assign volumes and to assign data services across each of these areas. And then obviously there's an operating model. How is my support team and my IT infrastructure team going to be able to manage across workloads in the cloud or clouds, as well as workloads on-prem? So I think that the data factory really becomes this concept of what is the standardization in both the technology and the operational layer that allows you to manage this as one single pool of resource, as opposed to what we've seen in the past, which is I have an Azure team, I have an AWS team, I have a Google team, I have an on-prem team. They're all different architectures. That's just not going to scale where we're going.
Okay. And Ted, do you have anything you want to add to that?
Yeah, just from my myopic component side of the world, I think that the core weaves and the neoclouds are going to be really important because they're going to allow access to enterprises that's going to be more specialized. And I think the key, listening to all these conversations today for me, is that the enterprises are going to have their own killer app or their own data pool that's very valuable, and they're going to want to do something with that. That's going to imply a specialized process that's going to need to be stood up and go. I think you're going to see people farm that out to neoclouds. I think the neocloud is the saving grace for the enterprise in the phase that we're in right now. I don't know what you guys think, but
yeah.
Well, one of the keys to that too is what Shawn was talking about, though. Don't forget in that move to the cloud or back to the cloud, one of the things that we've talked about for years is hybrid cloud. This is another instance of a hybrid cloud where but also don't forget that the architecture that Shawn mentioned at the beginning when he was talking about the move to the cloud, the application architectures have changed. Like, remember when we started this, we took your monolithic app, we dropped it in the cloud, and then so I ran it in a less expensive form factor, I guess I would call it. However, over time, that application's innards changed, and the way that it accesses other microservices and whatnot. I think that is a bit of the standardization that like Troy was asking in the question just now, that needs to happen. That is, right now there's a sort of a de facto direction, but what we've been talking about all morning here, I think this is going to change as we go through here. We're at the very beginning of this whole adventure too. We're what 18 months, 2 years into this thing.
Well, and Tom, let me bridge on that. I mean, if you even think about everybody's building their own, well, we know this is going to move to an app store. We know that models, both training models and inference models, we will build best practices and models around how to build these, but folks will be consuming and even buying and subscribing to these as a service. And so you talked about, I think it was Ted who talked about very specific data sets, right? Not only could those data sets potentially turn into a whole new business model where you're actually selling the inference of your data set as a service to the external market. If you think about options data in the financial side of things, you think about, even governments starting to share certain sets of data to better protect their citizens. But today, remember, everybody's trying this. Everybody's building it. Everybody's sort of, trying to figure it out. We haven't really crossed the chasm on collaboration where is there a marketplace model where folks can start to not only share what they've learned, but actually start to subscribe and consume from one another. And I think that's a massive opportunity.
I love that. I love that. The app store analogy is brilliant for this. Brilliant.
Yeah, and that's what people are talking about now, having, sort of agents collaborate together and there's a lot of sort of standardization efforts going on. 2 or 3 that are going on right now.
Well, think about it, guys. I mean, today, if I use DoorDash and I'm tracking my order, do you think DoorDash went and built a whole new app to track the driver from the time he leaves the restaurant to my house? No, they're subscribing to standard Google services that allow for that GPS to take place. And when we start to see that, I think we'll know we're evolving towards an architecture that enterprises will find much more palatable to bring into place. So it's all about standard operating procedures. And I can't stress enough, the early stage of AI is being built on basically the foundation of HPC, right? High performance computing. Everything is highly one-off. Everything takes a lot of human capital, a lot of human knowledge. There's a lot of folks figuring this out and writing code. But for this to really gain speed, it's going to build into a model where certain standards emerge. Those standards get integrated into applications and infrastructure and operations. And at that point, not only will the economics become far more palatable, but the operating model will be one that organizations will feel comfortable jumping into.
Right. And I have a question following up on that. When we talk about best of breed versus integrated solutions and the building blocks to connect, to cloud and the edge to manage as one stream of data in this cycle. Do you guys have any opinions on, how companies will decide what's going to be best of breed, what's going to be integrated, what they want to keep, internal and what they, in terms of privacy, compliance, security, things like that? It seems like there's a tornado effect in terms of all the options,
Well, there really is. And I think part of it is you have to separate away, the question of data, the data sovereignty, the processing, and then some of these other things. I mean, if we saw, cloud computing did this years ago, where there were 50 different solutions. Now we've converged on 3 or 4, and I think this has got to happen here as well. And that is going to lend itself to the market economics of this coming down. Shawn made a great point that this is really run on the tail of last generation of HPC. People need to understand this is the most expensive equipment that you can use. This is like using memory in a router. This is the most expensive memory in the universe that you're using.
Right.
And so the market economics of using the most expensive solution, not only to run and operate, but to develop, you're going to get what you get today. But as we, narrow things down and converge on some best practices, either the price will come down too of these things.
Right.
But right now, for a lot of for a lot of enterprises, it does not make any sense to go build an AI factory.
Right.
I know a number of enterprises that have gone out earlier this year and spent tens of millions of dollars building a data center in just because they're afraid they're missing out on something. And what
Yeah.
they realized 6 months later was maybe they should have waited
Yeah.
because they didn't quite know what they were going to use the thing for.
Right.
Because the assistive applications that they're using right now are actually from the cloud or somewhere else. They're not even running them locally.
Right.
Well,
So I have
that's a significant challenge. But I mean, Susana, I want to cover the one piece of your question that's
Yeah.
still out there, which is security and
yeah,
compliance.
and then we'll jump to some questions because we're going to wrap this up in a few minutes. So after you tell me
Yeah.
that.
So, I mean, put very simply, we have a responsibility in the build out of these architectures to essentially set the direction for the future. And if there are significant missteps early on data security, if people feel as though they are being exposed, it's going to present a serious headwind to deployment. And so all the organizations stepping into this, this new arena of AI have a responsibility to ensure that the data is kept secure and compliant beyond financial fines, beyond GDPR and California privacy and all of these things that exist. I do think organizations are taking a serious look at what is the security posture of these services. And you think of things like AI harnesses, and you think of new attacks that can come through agents, and you think of code injection through, AI coding. These are all significant issues that need to be looked at and assessed in the risk profile of rolling these initiatives out.
Okay. So there's a question for the panel. Someone wants to know, what role does the panel see software-defined networking play with scaling up AI production within factory of the future, the AI factory? Does anyone have an opinion about the software-defined networking aspects of this?
No.
Well, we have at my company, we have a very strong opinion because all of our products, our Ethernet switch chip and our DPU are all software defined. And what that means for us is a number of things. If you're a government, it means you can read the code of exactly what's happening inside the chips so that you can know they're secure. So for these kind of sovereign things and government applications, you have to have it be software defined. Okay, it's a requirement. For the rest of the world, the software defined allows you to change and modify the networking behavior as new applications evolve. You don't get stuck in a certain way of forwarding the traffic or filtering the traffic. You can adjust that. So it's a flexibility or an agility that we think is perfectly suited for AI right now, where we're still figuring out what it is.
And that also lends itself to addressing the security posture of all of this technology too. The SDN technology is, if we had tried to do this without SDN, we'd have other challenges.
Look, there's people doing extreme edge applications that require their own networking protocols. So they're solving problems that aren't traditional in routing, and they have to write their own services, their own packet services. So we know that SDN is required.
Right.
It's having its day. Our perspective is it's having its day now. It's beautiful.
Right. Okay.
Yeah.
And now I just, because we only have a minute left, I just wanted to tell the results of the poll of our listeners here. So where are you today in your enterprise AI journey? 9% said they are in limited production. 14% are in pilot deployments. 23% are in POC, POV, and then evaluating is 55%. So does that, are you surprised at all by that, or is that what you expected in the poll?
No,
not at all.
Absolutely not surprised.
Yep.
I think 2026, we will continue to see evaluating. Most of the pundits out there are thinking 2027, 28 to start to see some scaled deployments across the enterprise. But folks, let's not forget, this is an incredibly exciting space, right? These eras take 15 to 20 years. The last one we saw was the cloud. The one before that, whether we take things like ERP or whether we take things like the PC revolution, these are 20-year journeys. We are 2 to 3 years in. We are about 10% into this journey, and the evolution roadmap is enormous. So it's an exciting time to be in IT. In fact, probably the most exciting time. And I think it's, an opportunity to create trillion-dollar companies, but also to create career progression for individuals that have more colors on their palette than ever before and more opportunity to essentially show organizations what the future may look like. So it's exciting, and I'm excited to be here.
Right. Well, I'm going to wrap it up. If anyone that's been listening in wants to follow up with Shawn, Tom, or Ted, you can reach them on LinkedIn. We will have a report available on the site that ties to this conversation. And I want to thank you all for joining today.
Thanks.
Thank you all for having us.
Thanks, guys.
Thank you.
Thanks, Shawn.
Yeah, bye-bye.
Susana.